My name is Vinicius Biber from Fraunhofer IFAM. Today, I'm here to share with you the results and also how we can use or how we use OntoTrans to achieve the results from the App3 Composites Prepreg. As a translator partner, we have Fraunhofer IFAM, a team of a group of translators. As an end-use partner, we have Composites Evolution. So beginning with always the first step is the definition of the business case. And in this case, market, regulatory, and safety requirements drive the transition towards non-toxic, low environmental impact, and solutions for composites prepregs. Composites prepregs are it's usually for a composite you have a resin and you have the fabric, and you can either have them separately or you can have fabrics pre-impregnated with resin, which makes the process of manufacturing much easier. And especially innovative prepregs have a great solution for environmental friendly and more safe composites. And especially a specific group called PFAs. They are fire retardant, eco-friendly alternative to the common phenolic resins. And then you can see on the top part here, it's the manufacturing of a composite prepreg. And then as the innovation challenge was or the aims that were defined in the beginning of the project in a collaboration or in like a ping pong between the translators and the end user, was to improve understanding and control of process, improve quality of end products, reduce development time and costs, and create a model-based approach for future product developments. And also, as the previous colleague also presented, the second step that we used, we modeled the industrial case. Then, as you can see here, it's described the entire process from the resin preparation to the pre-pregging process, let's say cradle to gate, until the end, the finished prepreg. And then you have the one step more, which is the component manufacture, the composite manufacturing. And then at the end, you have the cured composite laminates. And also as an approach of the translation, we, as a translator, we acted as a surrogate customer. So usually the customer of Composites Evolution, the customer buys the prepreg, and they make the manufacturing in the industry. And then at the end, they want a composite laminate. So we, as the translator, we act as a surrogate, and then we received the commercial prepregs, and then we did the manufacturing ourselves. Also very important in part of the translation process and how the OntoTrans project helped us with this was as also presented the entire process, again, from the resin mixing, resin preparation, the impregnation, from the final prepreg until the step of having it manufactured following a given manufacturing technology, with us everything described with an EMO compliant application ontology. And also not only this, but also we have lots of properties that can describe the products and also the processes that we were having. Then, for instance, for us, we can have mechanical properties like tensile strength, tensile modulus, interlaminar shear strength, the size of the prepreg, the size of the composite laminate, the manufacturing steps, the curing temperature, the curing profile, the pressure, everything was described using EMO compliant application ontology. And also, as the innovation challenge, we had two specific cases, says here App3, but this is the App3. So the first, let's say, case was you have as an input, you have new process parameters like temperature, pressure, and geometry. And then you want as a client, you want the output, the expected mechanical properties. And as a second case, you already have defined which are the required mechanical properties. And then the objective is, as an output, then which are the suitable process parameters to obtain this required mechanical properties. So the first one, you're kind of constrained by the process parameters, and then you want to know what you're gonna get as mechanical properties. And the second one is kind of the other way around. You are bound by your required mechanical properties, and you want to know which are the suitable process parameters. Then also as KPIs, we have here, of course, measurable, and then we have the time to market. Of course, the faster, the better. The number of tries that you want if you have a new process, and then you want to do as with reduced number of tries as possible, and also the mechanical performance. And we have here two very important mechanical properties. One is the interlaminar shear strength, and the second one is the tensile strength. And then now on the step 3, so the analysis of the experimental data, we had mainly 3 groups of data. One is client's proprietary data. So this is information that would be, like said before, hidden behind a firewall. So they are internal measurements, resin formulation, tools, geometry, manufacturing price. So this is information that the end user would not want to, this internal information that should not be outside. The second, let's say, group of properties or data or metadata are the client's publicly available data, which is the product data sheet that contains information such as mechanical properties, fiber content, and density, and also the product sell price, because this is also an information which is public. And then also we realized during the translation process that we would need also additional data that would not belong or is not from the customer or from the end user, like benchmark values. So to look around and see which are the expected values of a given property, and also reference values of mechanical properties. But sometimes, as we show in the end, we did some modeling using, or we did some simulation, sorry, using finite element analysis. And sometimes you need some parameters that you can usually get experimentally, but to optimize your process or due to budget constraints, you can use benchmark values that can be very useful. Then as the process model going as an input, as of one case, so as an input, you have the temperature profile. So when you have a composite, it's like making, let's say in a very, very, very simplified form, it's like making a cake. You have all the ingredients there, and then you bake it. In this case, you cure it. You apply a certain temperature and a certain pressure. So in this case, it's a temperature profile. So it's, for instance, 1 hour by 90 degrees, and then with a ramp of a given temperature, and then you arrive at this certain temperature, and then you go, you keep that temperature for half an hour, and then you cool it down. And then you have the geometry, also the pressure profile. Then we did some TGA measurements, and then from the TGA measurements, we you get a weight temperature profile. So you see how your material loses weight due to the temperature, because it's losing moisture, or it's losing during the process. Based on this weight temperature profile, we have a data-driven model that we can predict the resin content, the ratio between resin and fibers, which is for us is one of a very important KPI. And then using this resin content, you have a finite element analysis driven model, then we can get the expected mechanical properties, which is our second KPI. So this is a very example. So here is so-called interlaminar shear test. So you have a small piece of composite here. Then you have this top part that presses it down, and the higher the value of the interlaminar shear strength, the better. Then we, of course, this is a manufacturing, this is a prepreg, and then it's in an oven here. And then in parallel, we can also do simulations that represent exactly the testing that we are doing, and then we validate our model. So the app tree was also implemented in the GUI of the open translation environment. So we can have an example here. We can upload the data, and then we can save it and use it later for our data-driven models. We also use it for visualization as well. And also, it was also shown this more, and then we are also on the ESS. So all the data, it's there on the ESS. And the advantage from OntoTrans, it's a data-driven approach, allows for a faster integration of new materials and processes. Data-driven approach allows the prediction of composite laminate properties. You have a faster response by manufacturer to customer requests, and then you have the time to market can be reduced based on data-driven approach. As a last slide, both as a translator and end user, the OTE provides a lots of tools, not only for app3, but for all apps. So I can say that for running simulations interface with OSPs, from data provenance, we have the OntoKB, the ESS, to define suitable KPIs, interface with the BDSS and ontology specification, and also, it's hidden here, so I think I clicked something here, but also how help guidance during the translation, so Epic specific GUIs, and also the OntoHack. So for app3, this is all, and then when we finish, I can answer your questions. Thanks.